Hi, and thanks for tuning in. I'm Theodore Summers, and this is joint work with Mark Ho and Tom Griffiths. I'm going to be discussing how shared context affects different forms of communication. So as a motivating example, imagine teaching someone to hit a forehand. One approach would be to give them expert demonstrations. Here, video of Roger Federer. On the other hand, you could provide a detailed explanation of how a forehand works. You could reference concepts like physics or gravity. You could clarify exactly what you wanted someone to do. You could even warn them not to follow an expert demonstration. So instinctively, language is very appealing for teaching. But what if the other person didn't know what gravity was? Taken to the extreme, what if the entire explanation was in a language that you didn't understand? Intuitively, demonstrations will work a lot better under these circumstances. So this motivates our research question. How does shared context affect different modes of communication? We use a two-player teaching game, and we vary the shared visual information between the teacher and the learner. The basic task consists of collecting objects from a level with different shapes and colors. The learner has 8 seconds to visit one cluster and select objects and sees the total score, but not the individual object values at the end of the round. The teacher, on the other hand, can see the underlying object values on the left, as well as what the learner sees on the right. At the end of the round, they have the opportunity to provide feedback. Here, sending a message that pink squares are actually worth the most. This interaction repeats iteratively for 10 levels in total, where the learner will play a level and the teacher will provide feedback. We use 2 manipulations. First, we varied the mode of communication. Linguistic or chat teachers were allowed to send unconstrained free-form text via the chat UI that you just saw. Demonstration teachers replayed the same round that the learner had just played while the learner watched. We also manipulated the shared context. So full visibility teachers saw the true object values as well as the learner's shape color view. In the partial visibility condition, we only gave the teacher the true object values. They could not see what the learner saw in terms of shapes and colors. The first analysis that we did was looking at the overall score to measure how successful communication was across different conditions. As a baseline, we used solo players with perfect information on the left, or no teacher on the right. For the full visibility teaching condition, there was not a significant difference between the scores of demonstration and chat teachers. On the other hand, reducing the shared context under the partial visibility condition had no effect on the demonstration scores, but resulted in a dramatic degradation of chat scores. The partial visibility teachers were essentially equivalent to no teachers at all. So this is a striking result, and it leads us to ask the question, how did behavior actually differ in these different conditions? Demonstration teachers tended to play optimally in both conditions. There was not a significant variation in score despite the change in context. The language, however, employed by linguistic teachers was extremely different. In full visibility conditions, the teachers were able to reference the shapes and colors directly, and they mostly talked about which objects were worth the most using shapes and colors. However, in the partial visibility condition, they lacked that shared context, and so they fell back to referencing spatial or behavior actions to indicate which objects were valuable. Finally, we can ask what concepts the learners actually acquired. Faced with this level, each learner has to choose a set of objects. This results in trajectories which intuitively reflect the learner's underlying belief about value. For example, that circles are worth a lot, that pink shapes are worth a lot, that yellow shapes are worth a lot, or if they went to the bottom left, that pink circles in particular are worth the most. So we know the true underlying concept values, and the question that we want to ask is what was actually learned. We use an inverse choice model to infer the most likely set of beliefs based on the observed trajectories. What we see is very interesting. So when we compare the recovered feature weights, we see that learners in the demonstration condition, that's green and red here, value circles of any color. However, only learners in the chat full condition value pink circles highly, which is in line with the optimal baseline of the full visibility players, the optimal players on the right, who are given perfect information. So we say that demonstration learners acquired a simpler concept, but linguistic learners acquired a more precise concept. In summary, we find that linguistic communication is much more sensitive to shared context. We see qualitative differences in learning across the modes, and we're excited about several lines of feature work, including varying the concept complexity, allowing the teacher to choose a mode of communication, as well as applications to machine learning, particularly in reinforcement learning. Thanks for your time, and please feel free to drop me a line. This is my email address.